Hello everyone. So today this is a part two from the video I just posted earlier. And so I forgot to mention something from the last video that I mentioned here today. So let's just get started. So again, we're still on recursion. This is the part where I talk about the table here. But I forgot to mention that I was going why this code should be simple. Some people do say that. In my personal opinion, I don't think it's intuitive or easy to figure out because it took me um a while trying to like break this down a little bit. Like how do you figure out the base case? Especially if you're trying to figure out the recursive case. That took me a little longer to figure out too. So I wouldn't say like this, if you're writing a program to write the factorial of 5, um, to me it's not very like simple to think if you spend enough time with it, if you spend a lot of time with it, then it becomes, easier to think about. But if you're somebody that hasn't really like practiced it a whole lot, let's say you just started or you're not even at that, let me give you an example. Like if you're a PhD computer science professor, or if you were from the industry, you have like what 40 years of experience or 20 years of experience. You spend a lot of time with coding, with programming, writing programs, computer science. That's what I meant here. But if not, it just you have to train yourself. You have to like really like sit down, pencil, paper, figure out the stuff. And I know sometimes it gets pretty tough. So I would say this program is easy to think about, but it takes a while to like to think about, to get your brain going. I know for me, um, it took me a while to figure this out, to like actually explain this to you guys and like really show you guys how I'm gonna do it. I'll explain it, but I'm just saying when I did this on my own, I was thinking, um, how am I gonna explain this to someone else? And so let me just get to the table here. So again, I kind of um, what I've done with this table. This table is just pieces of information from for our code. So if you guys remember, if you guys did a lot of programming, you guys probably learned functions, statements, and variables. If not, that's okay as well. I'll explain that as I move forward. So a variable is just to store information like data, like numbers, strings, sorry, characters, like letters, pretty like other stuff. So maybe you could store like the at sign, for example, like a shift two on your computers. Everyone has, shift two is the at symbol, like special characters is what I'm trying to say, if that makes sense. A statement is, think of it like an expression in math. Think of it like if I say, if you take this as in a statement here, like we said, n times n minus 1 factorial. That's a statement. Think of it's without the equal sign. So if that's easier to understand. Um, and then a function is a way to organize your code. So I'll get more into that or we go further down. But a couple things you should think about when you're doing functions is the return type, as I mentioned here, like what does this function return? As by that, it's like what value is going to return. Think of like a calculator. So when you do like 2 plus 2 in a calculator, you hit enter and then you get the number 4, right? Think of it like this. When you do 2 plus 2 in the calculator, when you hit enter, that means return. So whatever you let me explain this one. So 2 plus 2 in a calculator, the 4 gets stored into let's say the calculator's brain, right? Let's just say this. 2 plus 2, when you hit enter in the calculator, it means return. Think of it like that. Um, and then the return type just means what? Are you gonna give me a number when you see in the calculator? It's gonna be, something else. I hope that was clear. If not, let me know in the comments. Um, and so another thing to think about is the name as well too, like what you gonna name it. And it's very important in computer science how you name things. Like you don't wanna Like I could have called this program doing something that I could give it a different name, but I called it factorial, so it's easy to remember. It's like, oh, this is the factorial of 5, for example. That's what I'm working with for factorial. So names are very important in computer science. So make sure when you give names, be very clear and it's very like related to the problem, if that makes sense. Another thing I'll mention, oh, another thing I'll mention here too is that this is one way you can like do it. Like you can write out, okay, if I what functions what I need, what statements what I need, what variables what I need. That's one way of breaking this down. There's many other ways to do it. But in my personal opinion, I think this could be helpful because it makes you think about all the other stuff beside variables. To using it's like more tools you have to think about in your arsenal or in your toolbox, if you think of it that way. Like instead of like a lot of times when I was beginning, I used to think a lot of variables about what variables I should use, but I didn't think about the statements or the functions at all. So I think that's why I kind of set it up this way. If this doesn't make sense, let me know. Um, I'm gonna show you another way how I'm gonna order this around, but this logic here is like the steps. Where you're supposed to like it's the algorithm. It's like a step-by-step procedure to solve the problem. And so what I said, okay, we're gonna start the program, so I'm gonna declare integer n, and then I'm gonna print factorial 5. This is just a test run. I'm like I didn't like after I looked at this table, I realized the order's out of it's out of order. So what I should have done instead of printing factorial 5, let's declare the function because we're gonna need that, and then we can print it out. I'll explain a little bit more when we get down to that. But again, I just write this out in like English. Everybody has their own like unique way of writing an algorithm for this kind of problem. Like you might not say declare, you might say okay, store a variable, or you might use a different word than me. That's totally fine. It just I try to be careful with the words too with this because I'll try to translate this into code as well, which, the syntax of C++. Um, so that's one thing we're gonna do. So I have this something called pseudocode. Again, this is just writing how do you to solve the problem in English, the programming. You can write it however you want to. There's no actual rule for it. It just you have to make sure that whatever you write in pseudocode, you can translate into code easily. Like you don't want to have a hard time doing that, and that's very important. This is good for like, well, pseudocode is good for like coding interviews. Um, I don't know if anyone had a whiteboard interview. It's like where they give you a question, you have a certain amount of time to answer it, and you have to write it in whiteboard. You can't like go to your laptop and do it. You have to like use a marker and like write out how you're gonna solve the problem. So this is the best way that that helps you understand the problem. In my opinion, you don't have to do it this way, but I always use pencil and paper, and that's why most of the stuff you see here is like from pencil and paper. It's just to help you see the logic before you type it in into like leak code and trying to like run it. And so again, as I said, I'm going to start here. I'm going to declare an integer n, and then I'm declared uh, the function first. After I have declared the integer, I'm going to say, okay, I'm going to create this function. It's going to function called factorial. It's going to be void. By void, it's not going to return anything. So don't worry about it. If you do void, you shouldn't worry about the return type at all. Uh, it's a good way. It's good practice because a lot of times you might not know the return type right away, so just always use void if you're not sure what the return type is. And then, okay, and this is the function here. So remember when I said you organize your code? So let's pretend I didn't have this brackets here when I just had these two statements. The problem was the reason why I used a function is because once I get into like the print statement, I have to call it. And the best way to do that is instead of having just running this without a function, I can actually without the function, I have to run line by line. But then the problem is with the print statement is if I'm doing factorial 5, I have to name it. I have to actually give it a function because factorial is not defined in the C++ libraries or sorry, I'm getting ahead of myself. So like with C++, right? A computer knows, numbers like decimals, whole numbers, like floats, integers, strings. Now maybe the others, but those are the three that, that I remembered that a computer should know. So if I were to say, okay, give me the factorial 5, um, it's not gonna know what factorial is, because it's not defined in C++. So we have to define it for the computer. I hope that's a little bit clear. So that's why I have this function called factorial, because when we get to the print statement, it's actually going to be a function we're calling this function factorial to do something for us, or to print out the factorial 5. I hope that's clear what I'm talking about. If this is not clear, let me know in the comments and I can definitely explain it to you guys. And so by argument, just think of it like pretend without the word argument, it just means brackets and whatever you have inside of it. So this would be brackets, integer n when you do it on piece of paper, for example. And what this is it's just telling the function, okay, I have this integer n. It's defined already, so I know what n is. N is an integer. So if I use it here in this base case, uh, the function factorial already knows what n is. And so I'm going to go into this base case. If I said if n equals 1, return 1, because the factorial 1 is just 1. That's the smallest we get to. That's when we stop the the factorial or the recursion, if you want to say it that way. Because once we hit 1, that's it. Think back. Let me just show you. Like think back here. Remember how we did 5 factorial as in math? I mean, all the way down to 1, because 1 is where we stop doing the factorial. I hope that's clear. And so, again, for the recursive case, I want to just clarify something. This is where, let me just bring that to the math for a little bit to help you think. So remember how we said the n, if we have a number n, we're trying to find the factorial of it, well, we agreed it's going to be n times n minus 1 factorial. So the recursive part, think of it's right here with n minus 1 factorial, because each time you're doing the factorial, you have to keep doing it until you reach 1. So think of like 5 factorial, right? N is 5, it's going to be 5 times 4 factorial. I should write it like this. Hold on. Let me write it after here. So think of it 5 factorial as 5 times 4 factorial. So in here, we would have to figure out what is this 4 factorial? What is it? We don't know. So we had to do the factorial of 4 then. And then we keep doing this. So what I'm saying here, we're doing the factorial again. So we're figuring out the factorial of 5, but we also have to figure out what's the factorial of 4. And then we keep going down all the way until 1. I hope that's kind of clear what I'm saying. It's calling itself. That's another way of saying it. So if that doesn't make sense, think about it in the recursive case. You have to call the function itself. So again, the name of our function is factorial. So the recursive case, you need to call the function itself. So in this case, you kind of need factorial and something inside here for the recursive case. It's always the case, in fact, in recursion. I've seen a couple examples um, beside this one that where in the recursive case, it's always you're calling the function itself. It's like you're calling yourself again. Like this is okay. This is a you have a group of students again, and you're calling on your name. So you have Seth, Steve, and then you call yourself. And this is what I mean. And just to let you guys know, I kind of wrote it this way just to help me. Why I wrote it like with like if I'm writing code, with the brackets and the parentheses here. It's just to help me easily write this in code when I get a chance. When once I finish with this, I can easily write this in my editor, my VS Code, and then run the program easily. So in this n factorial, it's not part of the program. This is just to tell me this is the end of the function. You don't have to do it like this, or like write n factorial if you don't want to. I could have done also. I could have said like over here. Sorry, I could have said and if statement. I could have done that, but I didn't want to because I already know where the if statement ends. But you could if you wanted to. If it helps, definitely do it. And in the end, we'll print out the factorial of 5. By that I mean C out. And this double angle is just to say, okay, this whatever this is going to be printed out to the screen. Is another way of saying it. I hope that's clear what I'm trying to say here. So by this factorial of 5, what we're doing here is we're actually going to the function factorial and we're passing in n equals 5. Because think of this as n, right? That's a variable we put in into the function. So n is 5, and we're gonna get the factorial of 5. We're gonna run through this. So 5 wouldn't work for this, right? Because 5 does not equal 1. So we go to the recursive case. So then we return 5 times factorial of 5 minus 1, which is 4. And then we call the factorial again for 4. So and now n is 4, and then n is 3, and then n is 2. So when n is 4, we have factorial of 3 again. And then we call the recursive again. And then when we get to 3, we're going to have factorial 2, and then factorial 1. So when n equals 1, it returns 1. And so, if you guys want me, I forgot to show you the visual for the recursive part. Sorry guys. uh, what I'm going to do now is, so let me do it here then. Let's see if this is going to work. So I'll say, I'm going to use like a stack or like, I'm just gonna write out the parts here. So we have 5 times factorial of 4, right? And then when n equals when n equals 5, right? N equals 5. Okay, and now we have 4 times. Remember, we're following the recursive case here. I'm doing the visual for the recursive case. Um, so we're doing this part here. That's what I'm doing the recursive case, but I'm doing it on pencil and paper. And so when I do factorial of 4, it's going to be 4 times 3 factorial. This is when n equals 4. Okay? And when n equals 3, we have 3 times 2 factorial. This is when n equals 3. And then we have n equals 3, we have, sorry, when n equals 2, 2 times 1 factorial. This is when n equals 2. Now, this is the important part. Okay, when n equals 1, this is where we have to come up to the base case. So when n equals 1, we return just 1, right? N equals 1, return 1. So let's go down here. So return 1 when n equals 1. So now this is what I'm going to do. I'm going to backtrack. Well, I'm going back to the top, I should say. So from here, from this 1, I'm going to put this in this factorial 1 here. So now I'm going to have, um, this is top to bottom. It's not supposed to be, but that's what it looks like to me. Now we're going bottom, top. So now I'm going to have 2 times 1, which is 2. Now that 2 is going to go into that factorial 2. So this 2 that I, sorry. So this 2 is going to go into factorial 2. So now I'm going to have 3 times 2, which is 6. Okay, and then now this is going to go into 3 factorial, this 6. So 4 times 6 is 24. Okay. So now that, uh, oh yeah, 4 times 3 factorial. Now that 24 is going to go into the top, very top here, the very last step. So 5 times 24 is 120. Well, look at that. We actually got the answer, 120. Should be the same as what we did in math. Um, sorry, trying to find the, here's, see, wow, look at that, 120. The same thing, right? We did the same thing. We did 5 times 4 times 3 times 2 times 1, but in recursion. Wasn't that fun for you guys? um, what I, for this kind of uh, pencil and paper way to visualize the recursion, uh, if you have only one, uh, if you only have one function here, like you see this factorial n minus 1, if it's just one function you're having in the recursive case, use a stack. By stack, think of like a stack of plates, or I was gonna use it for this, but I forgot. This is supposed to be at the bottom, this 5 times 4 factorial, and you go all the way to this should be at the top, right? I kind of went in reverse order by accident. Um, the reason why I'm saying using stack is just to keep track of the recursion. Like, are you seeing the pattern here? That's my question. Are you seeing the pattern here? Like, as I go from to the bottom here, right? And I go to the top, I kind of I'm going to find my answer. I know that kind of makes sense here. Like, just make sure one thing you're not lost and you're not confused also. Uh, I don't mean that as a what I'm saying is if you guys are confused, that's okay. It takes some practice to get used to this. Like I said, in recursion was the toughest one I learned the pure science. And now I feel like I'm getting the hang of it now. It just took a little while. I swear, every time I did recursion problem, I saw recursion, I'm like, what am I gonna do? I have no idea how it works. I can't visualize the recursion. It was painful. So it was not easy. Again, just keep track of what's going on. That's what I recommend when you're doing this kind of problem. When you're doing when you're visualizing what's going on, especially with recursion, just keep track of everything. I hope that was clear, guys, what I'm saying. So again, now, and this is what we did here. We did this print factorial 5. This is what's going on in the when you pass in 5 into the factorial function. This is this is what's going on um, in a human perspective, but also what the program is going to do as well. I hope that's clear what I'm talking about here. Um, Oh, and again, I mentioned this step should be in the main section. So I mean the int main part of the C++ program. And step three, which is the factorial function, should be outside of the main method or the main section. Sorry, the main section. It just to help you. Usually, what I put on the top of the main. I did. It just depends on you guys. I mean, I don't know how you guys want to write this. If you guys want to write your function, um, uh, on the very top or right after after the main section. That's totally up to you guys. But I always put it in the very top, so above my main section for my functions. That's what I'm talking about. So I hope that was clear. I hope this logic it kind of helps you see what's going on. It gives you some ideas to try out. Um, so please subscribe to my channel and please share this video with your friends and family. Again, if you have any questions at all about this topic or about what I did here, please let me know in the comments. I'll definitely, as always, I do check out the comments if any for my videos. I do check almost every day. Uh, so let me know if you guys have any questions. So thank you guys so much. Hope this is clear. Have a nice day and take care. Bye bye now.